All right, in section 7.4, we're multiplying and dividing radical expressions. So when we are multiplying radicals, it's important to understand that you can multiply inside of the radicals. For example, if we have the same thing, I'm just going to use this space for a second. But if we have like the same root, like the square root of 2 times the square root of 3, you can multiply inside of that to be the square root of 6. If this, though, was the square root of 2 times, let's say, the cube root of 3, you are not allowed to multiply the 2 and the 3 together because they're different roots. Also, if there are coefficient numbers, let's say we have like 5 square root of 2 times the square root of 3. If you have a problem like this, what happens is you can still multiply the radicals and then the coefficients stay the same. If this was 5 square root of 2 times 4 square root of 3, then you would multiply these numbers on the outside, kind of like the coefficient numbers, to be 20, and then this would be the square root of 6. So that's basically how it works. So for letter A and letter B, we're using the distributive property, and we're basically multiplying the square root of 3 by 2 and the square root of 3 by the square root of 5. So the square root of 3 times 2, the 2 is not a radical. The 2 is coefficient number. So we would rewrite that as 2 times the square root of 3 like that. And then plus the square root of 15. Once you multiply that square root of 3 times square root of 5 and get square root of 15, you should always think or figure out, can I simplify that? Well, it's the square root of 15. 15 doesn't have any perfect square factors, so this would be the final answer. They're not like terms. There's nothing I can do to combine those further. For letter B, this would be 4 times the square root of 2, and then minus square root of 16. And again, every time you do this multiplication, you should think to yourself, can I simplify any part? And the square root of 16 would be able to be simplified since that's just 4. So we have here 4 square root of 2 minus 4. Go ahead and try the checkpoint. All right, so for the checkpoint question, we are going to use the distributive property. So we're first going to multiply the square root of 6 times the square root of 12, and then the square root of 6 times the square root of 3, or negative square root of 3. Or if you would prefer, you could also do this differently and actually simplify the radical before you multiply. And I kind of like that idea better. So 2 ways to do this. Square root of 6 times the square root of 12 would be the square root of 72 minus square root of 6 times the square root of 3 is the square root of 18. Once you have that done, then you're looking for perfect square factors since we are dealing with square roots. So the greatest perfect square that goes into 72 is 36. So I'm going to rewrite 72 as 36 times 2. And the greatest perfect square that goes into 18 is 9. So I'm going to write that as 9 times 2 and then simplify. The square root of 36 is 6. So that comes out of the radical, and we're left with 6 square root of 2 minus the square root of 9 is 3. So that comes out of the radical, and I'm left with the square root of 2. And look at that. We have like terms since we have the same exact radical. So 6 square root of 2 minus 3 square root of 2 is 3 square root of 2. What I was explaining at the beginning is that you could also, from the start, if you would prefer, to simplify before you multiply. The square root of 12 is the same thing as 4 times 3, right? So you can rewrite it this way. You can simplify the square root of 12 by pulling out the the square root of 4. So we have the square root of 6, and then we would have 2 times the square root of 3 minus the square root of 3. And when we do that, we can kind of see already here that we have like factors. 2 square root of 3 minus square root of 3. That ends up being 1 square root of 3. Oops, that should be a square root of 6 in the front. So once we get that, then we can multiply square root of 6 times the square root of 3. Well, that's the square root of 18. We could rewrite the square root of 18 as 9 times 2, and we'll end up with the same exact answer. I actually don't know which one requires more work. Actually, probably the second one. So up to you how you want to do it. Example 2 is using FOIL to multiply because we have a binomial times a binomial. When you have 2 terms multiplied by another 2 terms, you have to multiply first, outer, inner, last to get 4 terms that hopefully you can combine some things together to simplify it. So step 1, we're going to multiply 2 square root of 7 times square root of 7. That's going to be 2 times the square root of 49 because we can multiply the square root of 7 times the square root of 7. I'm going to show all of my steps and simplify in the end, but if you can skip steps along the way, please feel free. Then I'm going to multiply 2 square root of 7 times 1. That's going to be just 2 square root of 7. Then negative 4 times square root of 7 is negative 4 square root of 7. And negative 4 times 1 is negative 4. Now to simplify, the square root of 49 really equals 7. So this is really 2 times 7 here. So this first term is 14. 2 square root of 7 minus 4 square root of 7, I can combine those together to be negative 2 square root of 7, and then we have this minus 4 at the end, which I can combine with the 14 at the beginning. So we have here 10 minus 2 square root of 7. You could also write your answer as negative 2 square root of 7 plus 10. Pause the video and try the checkpoint. All right, to go over the checkpoint, first we're going to multiply 3 times 1, that's 3. 3 times square root of x is 3 times the square root of x. Negative, oops, I should do this one first. Negative square root of x times 1 is negative square root of x. And then negative square root of x times the square root of x, that's going to be negative square root of x squared. I'm going to simplify in the end. So once I do that, I have here like terms right here, 3x, or 3 times the square root of x minus 1 square root of x. So that's going to be 2 square root of x. And then minus the square root of x squared. When we know that inverses cancel out, so this would just be minus x. So we have 3 plus 2 square root of x minus x. You could rearrange this order, but basically you don't have any like terms here, so there's nothing really you could simplify this down to be. The next thing in this section is called conjugates. It's kind of a weird word, but if you read the definition and look at the examples here, the examples that I'm giving you are the square root of 3 plus 6 and 3 minus the square root of 6 are conjugates of each other because they're the same, but they differ only by sign, meaning one has a plus sign, one has a minus sign, but they're made up of the same components. We know from our entire factoring unit that when you multiply things that are like this, that are almost the same, but they differ by sign, then what ends up happening is it's really just the first term multiplied together minus the second term multiplied together, which is helpful. I'm going to show you all the work in the beginning, but it's helpful to make these conjugate problems a little bit easier. So example 3 is asking us to take an expression and multiply it by its conjugate. Some of the WebAssign questions that I assigned are going to give you an expression like 1 minus the square root of 3, and it's going to ask you to type in what its conjugate is. So the conjugate of 1 minus the square root of 3 is 1 plus the square root of 3. And what these are asking us to do are multiply each expression by its conjugate. So if I was to multiply 1 minus the square root of 3 times 1 plus the square root of 3, just knowing that I have to FOIL this, I'm going to start with the first. 1 times 1 is 1. Outer, 1 times the square root of 3 is the square root of 3. Inner, negative square root of 3 times 1 is negative square root of 3. And last, negative square root of 3 times positive square root of 3 is negative square root of 9. Then we simplify. When you multiply conjugates, the middle 2 terms that you multiply will always cancel out. That happens every single time with conjugates. It's the same thing as like x plus 1 times x minus 1. If I was to multiply this out, this ends up being x squared minus 1. This is a difference of squares. Conjugates are kind of like difference of squares, but we're not dealing with like polynomials anymore. But making those connections, same thing happens here. The middle 2 terms cancel out. So these cancel, I'm left with 1, and then the square root of 9 is 3. So 1 minus 3 is negative 2. And the answer is negative 2. All right, for letter B, we have the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2. If doing the entire problem every time, even the middle 2 terms is helpful, then do it. But if you memorize that when you multiply conjugates, you only really have to multiply the first terms and the last terms, then it just saves you 2 steps, basically. So the square root of 5 times the square root of 5 is the square root of 25. And if you understand right from the start that that just equals 5, then save that step. And then the square root of 2 times negative square root of 2 is going to be minus the square root of 4. And the square root of 4 is 2, so 5 minus 2 is just 3. If me skipping those middle 2 terms is confusing, then please make sure you just do it. Pause and try the checkpoint. Okay, the checkpoint. We're multiplying conjugates. I'm going to just multiply the first and the last. The square root of 10 times the square root of 10 is the square root of 100, which is 10. And then negative 3 times positive 3 is negative 9. So 10 minus 9 is 1. Multiplying these conjugates, the square root of x times the square root of x is the square root of x squared, which is x. And then times 2 times negative 2 is negative 4. So we get here x minus 4. All right, example 3 is dividing radical expressions, and this requires us to rationalize the denominator by using this new thing called the conjugate. So for these problems, the directions might say simplify. The directions might say rationalize the denominator, but basically whenever you have a fraction and you look at the fraction's denominator and that denominator has a radical in it, you have to get the radical out of the denominator, and you do that by rationalizing the denominator. We already learned how to do this, but the thing with these problems is that the denominator is now not a single term. So as soon as we add a minus sign or a plus sign in between 2 separate terms that are not like, then that adds to the process of rationalizing the denominator. So here's what you have to do. To rationalize the denominator, you multiply the entire fraction by the denominator's conjugate. So 1 minus the square root of 5 is the expression. The conjugate of this is 1 plus the square root of 5. So we have to multiply the numerator and the denominator by the conjugate of the denominator so that the denominator does not have a radical in it anymore. So when I do that, it just opens up multiple multiplication problems. The numerator is going to be a distributive property problem. The denominator is technically a foiling problem, but we know that when we multiply conjugates, you only have to multiply the first and the last. So let's take this step by step. Let's simplify the numerator. So the square root of 3 times 1 is the square root of 3. The square root of 3 times the square root of 5 is the square root of 15. Over the denominator are conjugates. So we only have to multiply the first and the last. 1 times 1 is 1. And then negative square root of 5 times positive square root of 5 is negative square root of 25, which is going to be that negative 5. So simplifying this further, we get the square root of 3 plus the square root of 15, which cannot be simplified. And then 1 minus 5 is negative 4. So that would be your final answer. Looking at letter B, same type of thing. We look at the denominator, and if the directions said simplify, these directions say use the conjugates to rationalize the denominator, whatever. But basically, the denominator cannot have a radical in it. Right now, it has 2 radicals in it. The only way you can get rid of radicals that have multiple unlike terms is by multiplying the entire fraction by the denominator's conjugate. The conjugate of the square root of 7 plus 2 is the square root of 7 minus the square root of 2. I think I said the square root of 7 plus 2. I should have said the square root of 7 plus the square root of 2. But anyway, we multiply the numerator and denominator by the square root of 7 minus the square root of 2. We're not changing the value of it. Essentially, that still equals 1, but we're changing what it looks like to get the denominator to not have any radicals in it anymore. So the numerator is a distributive property problem. The denominator is technically a foiling problem. 5 square root of 2 times the square root of 7 is 5 times the square root of 14. Minus 5 square root of 2 times the square root of 2 is 5 times the square root of 4. I'm going to simplify in the end. The denominator, the square root of 7 times the square root of 7 is the square root of 49, which is just 7, and then minus the square root of 2 times the square root of 2 is the square root of 4, which is 2. I could have simplified this part right up here at the top, but not to confuse and do too many things at once. 5 square root of 14 can't be simplified. Minus 5 times the square root of 4 really is equal to 2. So I can rewrite that as 5 square root of 14 minus 10, and then 7 minus 2, which is 5 in the denominator. So I get 5 square root of 14 minus 10 over 5. And then once I get that, I should be looking at all of the different terms and noticing that I can actually factor out a factor of 5 from all 3 of these parts. So 5 square root of 14 minus 10, if I factor out a 5, I'm left with this. And if I then notice that I can divide out 5 from the numerator and denominator, I'm left with the simplified answer of the square root of 14 minus 2. Letter C just becomes a little bit more difficult because we're adding to the process, but no worries. We know exactly what to do. First, we're going to rewrite what it looks like. So right now it says 1 divided by the square root of x minus the square root of x plus 1. And now it looks more so like the fraction that we're used to seeing. And once we see that the denominator has those radicals in it, we know that to get rid of radicals, we are going to be multiplying everything by the conjugate of that. So the conjugate would be the square root of x plus the square root of x plus 1. We multiply the numerator and denominator by it. Well, thankfully, the numerator of this fraction right here is just 1, so really no distributive property problem has to happen. We're just going to be left with the square root of x plus the square root of x plus 1 in the numerator. But then the denominator, it just gets a little bit confusing. So multiplying this all out, making sure that you understand is helpful at times here. So when we're multiplying conjugates, the middle terms cancel out. So we really don't have to multiply them. We just have to multiply the first and the last. So the first, the square root of x times the square root of x. You can multiply these two things on the inside, and then you'll see that it'll cancel out. Or if you realize that this is just going to equal x, it makes it nice and simple. And then same thing here, square root of x plus 1. I guess the first one's negative, times positive square root of x plus 1. If we were to multiply this out, we technically would have to multiply the x plus 1 times x plus 1. And we would have to like FOIL it out. And then when we take the square root of it, it would end up just being x plus 1. So we might as well not actually do the multiplication of it. Just realize that it's going to cancel out and it's going to be negative x plus 1. So we have x minus x plus 1 here, and it's the entire quantity that is going to be subtracted. So it's important to keep the parentheses there because it's going to be a negative of the x plus 1. So when I go to simplify this, it's really going to be x minus 1, which means the x's cancel. And we're just left with a negative 1 in the denominator. Could you leave your answer like that? Sure. You also could basically divide the square root of x by negative 1 and get the negative square root of x, and then positive square root of x plus 1, divide that, and then get negative square root of x plus 1. And this would also be a correct answer. Okay, so below we have just 2 checkpoint questions. So go ahead and pause, try them, and then hit play. All right, for number 1, we are going to multiply by the conjugate 2 plus the square root of 3 over 2 plus the square root of 3. Numerator is going to be a distributive property problem. 4 times 2 is 8. 4 times the square root of 3 is 4 square root of 3. And then the denominator technically is a FOILing problem, but we only have to multiply the first. 2 times 2 is 4. And the last, negative square root of 3 times positive square root of 3 is going to be negative square root of 9, which is 3. So 4 minus 3 in the denominator. 4 minus 3 is 1. So we just are going to be left with 8 plus 4 square root of 3 over 1, which is just 8 plus 4 square root of 3. For number 2, we're going to multiply by the square root of 6 minus the square root of 2 over the square root of 6 minus the square root of 2. The numerator is a full-on FOIL problem, and that's because the numerator does not have, the numerator expressions are not conjugates. So multiplying this out, 2 square root of 6 is 2 square root of 6. 2 times negative square root of 2 is negative 2 square root of 2. Negative square root of 3 times the square root of 6 is negative square root of 18. And then negative square root of 3 times negative square root of 2 is going to be positive square root of 6. So that's my numerator, which I will simplify later. And then my denominator we have conjugates here, so I really only have to multiply the first and the last. The square root of 6 times the square root of 6 is the square root of 36, which is 6, minus square root of 2. Square root of 2 is going to be square root of 4, which is 2. So my denominator is just going to be 4. Let's simplify. So the numerator, a couple things that I see right off the bat: 2 square root of 6 plus square root of 6. Well, that's going to be 3 square root of 6 minus 2 square root of 2. And then the 18 here, I should be simplifying that if possible. 18 has has a perfect square factor of 9. And it's not 9 times 3, sorry, it's 9 times 2. So I'm going to simplify this to be just like this. Let me do it on the side. So the square root of 18, same thing as 9 times 2. Take the square root of 9, it's 3. So we're left with 3 square root of 2. So rewriting this as minus 3 square root of 2, we can see that more simplification can happen because I can now combine these like terms. So then we get the 3 square root of 6 minus 5 square root of 2. That's our numerator. And our denominator, which I never simplified or put into it, is 4. Look at the coefficients: 3, -5, 4. A way to tell if you can or cannot simplify further is by looking to see if they share any common factors, and they do not. So that would be your final answer. Okay, use the rest of the period, please, to work on WebAssign.